So now what I want to talk about is the abstractions that Hadoop provides and sort of the way users think about Hadoop. So there are many different users inside of your organization. Some of them are going to be engineers and programmers. Some of these are going to be analysts or sort of people that are very familiar with working with SQL-like systems and producing reports and things like that. Researchers may want to ask sort of more ad hoc questions about your data that, maybe they don't want to like formalize this in terms of the report. Maybe they want to ask 10 different questions during the day, but they're not quite programmers, et cetera. So I'm going to talk about each of these groups of people. The important thing to understand about Hadoop is it provides you a single user accessible volume. So all of your data in Hadoop is accessible and available to everybody. And that Hadoop provides various abstractions that allow you to really focus on the data rather than the underlying system challenges of working with terabytes to petabytes of data spread across thousands of machines. And there are a couple different programming and querying languages and abstractions that you can work with here. The sort of native quote-unquote language for Hadoop is MapReduce. I talked about that a little bit. This was a model that was invented by Google, designed explicitly for data-intensive programming. You can sort of write your native code in Java, but you can also write, you can also use any other programming language you want through the streaming interface. So if you really like working with Python or you really like working with Perl and you want to sort of write in the core sort of native MapReduce mode, you can do that through streaming, and it is possible. One of my personal favorites is a system called Hive. It provides a SQL interface to Hadoop. So earlier I talked about you're going to be ingesting all of this data, and you don't exactly know what format it's going to be coming in or what structure it's going to be coming in. Hive allows you to impose structure upon this data at a later point in time. So you've ingested all of this data from all these different sources, and maybe one of these is a tab delimited file, and another one that you got from a different source is delimited with Control A, or pick your favorite delimiter. The guys over at Facebook here, not unnotably as she's sitting in the audience here, developed a system called Hive to allow them to really use Hadoop like a data warehouse and a business intelligence platform, because you have all of these users in an organization that are very comfortable with SQL. They understand SQL. They know how to ask questions in SQL. You ask them to go and learn MapReduce, and they're like, I don't want to learn MapReduce. I just want to use this thing I know how to use. So Hive is it's a great bridge because it works on the same data. The data is all still in Hadoop. So you can have your analysts asking these quick ad hoc queries. And the thing is, if they're already only used to asking questions in SQL, they don't really know how to ask like really big data questions anyway. So you can oftentimes use SQL, like Hive, as a bridge, so they can still work with the data while maybe your engineers and your programmers are coming up with sort of more complex data processing pipelines in MapReduce that allow greater transformations of data that then maybe generate tables that couldn't exist before. Maybe it's a table that isn't present in any of your current databases, but when you run through this data processing pipeline, you now get this table that is actually very interesting to run standard SQL queries over. And so this is something that makes it very easy for people that have never thought about Hadoop, who are more comfortable in SQL to work with this data. The other language that I want to talk about is Pig. This is something that was developed at Yahoo. It's a higher level language that's very commonly used for ad hoc analysis. Writing in MapReduce, you'll find yourself repeating yourself a lot. Like writing a join in MapReduce is the same, a couple hundred lines of code. There's a lot of sort of common aggregates, common sort of functions that you want to do in the reduce. Pig takes a lot of these sort of higher level principles, higher level operations that you like to do frequently, and puts a language on them that people are, it's not like SQL, so it's still a new language to learn. The analogy that I'll frequently draw here is that MapReduce is your C++, and Hive is your SQL, and Pig is your Python. So it's different users, different programming languages, but the point is that they're all working with the same set of data, and they can all access all of the data. And what you'll start to find is when you enable all users in your organization to interact with these huge volumes of data, two things happen. One, you start to drive a culture around data. Like you start to get people to stop arguing about their gut and their intuition, and they go and they look at the data. This can do wonders for political battles in organizations. This can do wonders for people arguing about what we should do or what we think we should do. But the other thing that you'll find is when you enable everybody to work with large-scale data, data begets data. All right, so you'll start to realize that there's derivative data now that you can create from your raw data, which is very valuable in and of itself. And maybe one researcher or one analyst will come up with some really cool transformation on the data or really cool report that they can generate, which someone else can use in a way that the first person who created it never even imagined. You know, and you start to just see these, you know, this emergence of new ways to think about data, and it really, there's nothing that makes me happier than to sort of see an organization start using Hive and Hadoop together, and start to, you know, come up with questions that they never even imagined asking before because they didn't realize what they could do when all this data was made available to them.